All right, we're down to the last two problems on the study guide, number 19 and 20. I went on and wrote the formula down and some other details, so let me go ahead and read it to you so we can get everything taken care of. Elizabeth was talking to her parents about what a good deal compounded interest was for a retirement account. She wondered how much money would she have if she invested simply $2,000 at age 20 at 2.8 interest compounded quarterly and left it there until she reached 65. So, determine what the value of her 2000 would become. They're giving you the principal, so we're just going to substitute that in for the principal, 2000. The rate is 2.8%, which is 0.028. And the number of times compounded, well, it says quarterly. And if you remember, quarterly means 4 times in a year. Well, the time is going to be found by subtracting. If she's age 20 and she's going to take it out when she's age 65, what is the difference in this? Well, it's 45 years. So that's what we're going to put for the time. Now just substitute all these numbers into this formula up here, and you should get $7,019.96. Not that much for 45 years, but the initial deposit's not that much either. All right, so this is still talking about Elizabeth. Question 20. She decides to try investing $2,500 this time at age 25, which is she's older at this point. And the interest is a little bit less. It's 2.65%, but it's still compounded quarterly. So how much would that be worth when she reached age 65? So that means our principal is a little higher, 2,500. Our rate is a little lower at 0. I wrote my decimal wrong. Let me fix that. That rate should not be that. It should be 0.0265. And then the number of times compounded is still quarterly. And reaching age 65 this time means we're just going to take 65 minus 25. So it's less years. It's only 40 years difference in the time versus the other one being 45. If you put all of this into the compound interest formula here, you are going to get $7,190.75. So it says, compare your answers for problems 19 to 20. What are your conclusions? Well, when she invests $2,000 at 2.8% interest over 45 years, she got $7,019. But when she invested 2,500 at a lower rate in only 40 years, she's getting more. So your conclusions could be that she will earn more. She will earn more with a higher rate. I'm sorry, with a with a higher deposit, because that's what was different. The deposit went up, the rate went down, and the time went down, but she will earn more with a higher deposit in less time. Oh, even with a lower rate. Well, slightly lower, but even with a lower rate. It's kind of sloppy. It just says she will earn more with a higher deposit in less time, even with a lower rate.